Hello friends, welcome to our channel Knowledge Amplifier, and in this particular video I am going to discuss about one project. The project is basically structured as a course. So what you need to write, you just need to write Image Processing Onramp MATLAB, okay, and just hit enter, that is search. See, first link you will be getting, go to that, and here you have the button to launch the course. I am launching this course. First you have to log in, make sure you have logged in your current account, so that when you will be getting the certificate will be having
and
your
welcome
name. Okay, so first some video introduction to what is digital image processing, all these things are there. If you want, you can explore. I am going to next. Okay, so here what is the fundamental thing we have to do? Basically this is the steps in any image processing related project. First we have to import the image, as you know. Okay, then we have to pre-process that. Okay, pre-processing can include several stages like converting RGB image to grayscale, image intensity adjustment, okay, or histogram equalization, all those things. Then segmentation. Again, segmentation has different ways, like we have seen graph cut segmentation, we have seen machine learning based method, that is k-means clustering algorithm for image segmentation, using which we decrease the distinct number of colors present in an image, right? Then apart from that, simple image segmentation, right, like thresholding based image segmentation, which works based on intensity level, all those things we have observed. And if we segment, the next step comes post processing. Why post processing required? Because it might happen that after segmentation some noisy parts coming. Okay, suppose you are doing thresholding, but some particular part is coming as noisy part. Okay, that is unnecessarily small white objects appearing somewhere. All those things we have to handle in this next stage. And then the last step is classification, okay, where we might train some machine learning model and work on that, right? So this is one simple workflow for any image processing project. Broadly here you can just go through this. Prerequisite is MATLAB Onramp, which is one particular course beautifully arranged to get fundamental idea about MATLAB programming. You can explore that. Obviously it will be having benefit, no loss, only win-win condition. Okay, you will be getting one certificate which you can showcase in your interview process, also related to computer vision or digital image processing, right? So now going to next. Okay, we have completed our chapter 1, and let us go to the next chapter directly. And how much you have completed, you can see here the status. Like here, for this time being, we have completed 6%. Okay, now in the first stage, what we are going to do, we are going to work on the first stage of an image processing project, that is importing. Okay, that is in current directory, or maybe somewhere my images are present, we will be taking that to our MATLAB current workspace, right? That is this image depicting. I'll be closing this. Now see here what we have to do, what is the theoretical background required, it is given, and this is the task which you have to do. If we unable to solve this particular task, then surely we will be going to the theoretical intuition or background part. But as most of the topics related to image processing I have already covered, so I am directly going to the task. But if you are doing this particular image processing domain related work for the first time, then I will suggest you, or strongly suggest you, I can say, to go through this particular background and explore from internet. Okay, because Google has everything in free, just you need to explore and search properly, right? So here is the first task: load image img_001.jpg into memory and assign it to variable I. Remember to use semicolon so that the value I are not displayed. Alright, the code will be very simple. I equal to im read, inside quotation I am going to write img, okay, _001.jpg, okay, right? And according to the question we have to give semicolon and submit this. If your code is completely correct, you will be getting all correct, otherwise it will be showing something wrong happening in your code, and according to that you need to modify. Okay, now when first task is executed, you have to go to next task. What is next task? Display the image data stored in I. Okay, that is nothing but the function is, as you all know, im show I. Okay, right? We'll be submitting, nothing new till now. Okay, we have already studied this, right? Go to next task. See, before going, it is, what is this image? Just try to observe. This image is nothing but one receipt image. Okay, maybe in from some grocery store or some big bazaar like that, you have done some shopping, or maybe some shoe store, bag store, whatever, does not matter. Okay, so that kind of thing it seems, right? So till now we don't know what is the problem statement we are going to encounter in our future. It might happen that we need to maybe classify whether a particular image, captured image, is received or not. Like that also it might happen. Okay, so let's go to task 3. What is task 3? Load another image img underscore 002.jpg into variable i2 and display it. Remember to use semicolon, right? So that means whatever we have done in task 2 and 3, if I just copy paste and change this name accordingly, I'll be getting the result. Okay, so here I'll be writing i2, and here also im show i2. Okay, and this will be img002. That's all, and let's submit this and let's check whether we are getting correct output or not. Yes, all these 3 are correct, and this is another image of receipt. Okay, right, go to next. Task is display the image stored in I and I2 as montage. So as you know that to show any image side by side we use montage, and for that we need to use im show pair. If you forgot this syntax, no need to worry, here in the background part they are clearly explaining. Okay, right? So im show pair, right? And then I comma I2 comma montage. Okay, and here we are submitting. Let's check. Are the images are displayed properly in montage? See, this is the first receipt image, this is the second receipt image, side by side it is showing. Perfect. Go to next task. So this is future practice. If you want, you can go through that. If you don't want, you can go ahead. Okay, because this is not compulsory part, but you can just explore. See, like here they are explaining about im write function, which is used to write some image from our workspace to our folder, so that we can take that image and use in our later purpose. Okay, right? So just if you want, you can go to click to next session. Okay, and here one video is coming and you see 12% is completed. So if you want, you can explore this particular video, or you can go ahead. Right, I am going to next. Right, so here what they are trying to discuss, color planes in receipt image. Okay, as you know that if any image is having RGB, that is color form representation, then red channel, green channel, blue channels are there, as we can see here. Perfect visualization, right? So the question task is that read the image img underscore 003 jpg into variable I and display it using im show. All right, very simple. I equal to im show of, I will be writing the image name img. Okay, I'll be giving tab and see the image is coming. Okay, right, and here I am giving semicolon, and here I am writing im show I, and let's submit this particular task. Let's check whether we are getting correct output or not. No, some error is coming. Expected input, what is that? Read the image variable display using im show. Does I contain the correct image? Okay, let me just verify once what is the problem. Does I exist? Is the image displayed? Yes, image is displayed. Expected input number 1, I to be one of this type, double, single. All right. im so img003.jpg. Read the image. Inserted its type was MATLAB graphics primitive. Let me check once what is happening. Okay, so here whose of I, sorry, MATLAB graphics primitive image, but this should not happen anyway. Yeah, it is displaying properly, but why it is showing a error here? Okay, let me just write here CLC. Let me submit once more. Double string, instead of type, instead its type is primitive image, validity distribute, numerical, logical. Okay, suppose you are getting this kind of error once, then what you can do, you can go to hint. Okay, just go to hint, right, let me close this, and use imread to load the image. Oh, sorry, my bad. Here actually I have used imshow. This will be imread actually, sorry. imread for reading the image and imshow to display. Let me go to next task. So the next task says that find the size of the image and store the result in sz. sz equal to size of my image I. Okay, let's submit this. So this image is also one received image which is having size 600 cross 400 cross 3. All correct. Go to next task. So extract the red channel, okay, color plane of RGB image I and store in R, display R using imshow. Alright, so R equal to my image is I colon comma 1, okay, because red channel is the first channel, and then here imshow R, right? So let's submit this and let's check. Alright, so see, all correct. So this is our only red plane, okay, right? So this is also a received image, as you can see. Go to next. Okay, now find the largest value of the red plane R and store the result in R max. Alright, so R max equal to max of R, okay, right? But it is one matrix, right? So either you can write like this, max of R, then also you might get correct result. Let's see. See, all of these are correct, but here I have used some other code. Actually they are suggesting you to use this particular one. Okay, so max of A, that is the image you have to pass, and then you have to pass this particular empty square bracket because you don't want to pass something here in the second input parameter, and then all, using all option find the maximum across all values of the array. But if you want, you can understand that this is two-dimensional, so max of max we can use. Let's go to next task. Okay, find the minimum. Just I'll be copying this and pasting here, and here I'll be writing R minimum, and here I'll be writing minimum of R. Okay, and let's submit this. Okay, let's check whether we are getting correct or not. So maximum value is 255, minimum value is 0. As we can understand that minimum value appearing for this black color text, okay, right, and the white color is 255, right? Let's go to next task, and here our task finish. Future practice, if you want you can practice. Let's go to our next session and let's explore what else we have to do, right? So here they are discussing about conversion from RGB to grayscale. Okay, conversion from RGB to grayscale is very important, because once you have converted to grayscale, you can apply morphological image processing either in grayscale domain, or just threshold the grayscale image, convert to binary and work in the binary domain, right? Lots of opportunity we can get in morphological image processing, right? And that full utility we can do in grayscale or binary domain. So it is always suggested that it is very important sometime to convert our color image to grayscale image, right? So here let's close this. Already 16% completed, and then here what it is saying, see here some piece of code is already given. Sometimes it might also happen that some piece of code is given, and you can see this is another received image only. Okay, right, the task is convert the RGB image I to grayscale image and store the result GS, display GS, right? So very simple, just we need to convert this image to RGB to gray of I, okay, and then display GS. That's all. Let's submit this and let's check whether we are getting correct answer or not. See, correct answer. So you can understand this is our grayscale version. You can understand that this is colored image, because you can see that this particular ink has certain bluish type color, but here this is completely black, white, gray range color, right? So let's go to next task. Find the size of GS and store the result in SZ. Alright, so SZ equal to size of my GS. Okay, let's submit this. Obviously we'll be getting M cross N type, not cross 3, because this is grayscale image. See, 600 cross 400, but previously we are getting 600 cross 400 cross 3 for one image, right? And here our task also finished, right? 19% completed. All right, we are going pretty good. Now coming to next session. Okay, so now this time we have to work on histogram related things. Okay, that is contrast, changing contrast, improving the visibility of the image and all those things, which I have already covered in image processing playlist, right? So I am closing this and directly jumping to the task. So here another piece of code is given, 2 images it is reading, converting from red to gray. Okay, so RGB to gray you can use, or IM to gray is also an function. IM show pair, using that montage format it is showing. So both are received images, and task 1 is display the intensity histogram for the grayscale image GS. Very simple, IM hist of my GS. Okay, and I'll be submitting this. Let's hope that we'll be getting correct histogram plot, and see, this is our histogram and both answers are correct. So here point to be noted, observe very carefully. Here GS is basically for this first image. First image is this one. You can understand that most of the pixels in this particular first image are towards bright side, right? And as most of the images are towards bright side, so in the histogram also see huge frequency is there present for white side, but very less amount of frequency present towards black side. So like this you have to interpret from the visualization, then only you can understand what you have to do next in the image processing step. So let us go to next task. Display the intensity histogram of GS2. Just simply I'll be copying this and pasting here, and here I'll be writing GS2. That's all. Submit this and the job will be done. Obviously we can understand that GS2 is the second image, which is, if you observe, this image is little bit darker than first one. So kind of almost all the pixels will be trying to follow one certain distribution. Okay, this is not like that kind of skewed. Okay, see, as expected this side also many pixels are coming. All right, let's go to next task. What it is saying, adjust the contrast GS2 and save the result in GS2 ADJ. Display GS2 and GS2 ADJ side by side using IM show pair function with montage option. Alright, very simple. So the function to change the contrast, as you know, is IM adjust. If you don't pass any more parameters, input parameters in IM adjust, what it will do basically, it will make lower 1% of pixels to 0 and upper 1% values to 255. That is, it will saturate lower 1% and upper 1%, right? So that is how this kind of transformation will be happening, and simply what we will be doing will be doing the task what we have to do, right? So here I will be writing GS2 ADJ equal to, GS2 ADJ equal to IM adjust of my image, actual image is GS2, right? And here I'll be doing IM show pair of GS2. GS2 is which image? GS2 is basically this one, right? This image. So you can understand that for this image we can improve the contrast or visibility, right? Using contrast enhancement IM adjust function, right? So GS2 comma GS2 ADJ comma montage, right? And let's submit this. So let's hope we'll be getting for all this correct result. Yep, we got. And see, this one has more contrast than this one, right? This is little bit fade, not that much clear, but due to application of IM adjust, the darker become darker, brighter become brighter. Okay, right? So all right, let's go to next task. The histogram of the adjusted image will reflect change made by IM adjust. Darker pixels will shift toward lower bins, white bright pixels will shift towards higher bins. Display the intensity histogram of GS2 ADJ, right? So here I will be writing IM hist of GS2 ADJ. That's all, and let's submit this, right? And here All this correct. See, this is the histogram after applying contrast enhancement, but here you can see most of the pixels are basically coming towards a single region, okay, but due to intensity adjustment or contrast adjustment, what is happening, it is trying to spread out, right? And future practice, if you want, you can explore. I am directly going to next task and then here next session. One more video again displaying. I am directly going to next. If you want, you can explore that video, okay, because I don't want to waste the time which I have already discussed. All right, now here complete part is basically future practice, so I am directly going to next session. And you have reached the end of chapter 2. Next chapter, here 32% we have completed. So importing done, then pre-processing. In the pre-processing stage, what we have done, we have converted the RGB image to grayscale image, and the grayscale image we have adjusted the intensity, okay, that is using im adjust function, and we have seen the histogram plot also. Now the next type is segmentation, and here we are going to apply thresholding based image segmentation, okay. So here videos are there which explains many things, okay, you can explore that. I am going to next, right? So here intensity based thresholding is discussed. You can see that this is bimodal histogram, so in this particular one middle part we have to choose our threshold value, and this image, if we threshold like this way, we will be getting this black part is 0, white part is 1 as expected. So I will be closing this now. So what is the code given? They are reading one image, converting from RGB to gray, adjusting the intensity and showing that, right? So what is the first task? First task is create the binary image BW by thresholding GSADJ. What is GSADJ? That is this one. Add image adjusted format of the grayscale image of this IMG_001, right? And we have to choose the threshold value at the half of the maximum possible intensity, and we have seen the max value is 255, right? For grayscale it is quite obvious, and display BW using IM show, right? So what we'll be doing, BW equal to here we'll be writing GSADJ, and it should be greater than, here I'll be writing floor of 255 by 2. Why floor? Because always this unsigned integer 8-bit representation format can take integer value, so I am converting to floor. So any value greater than this will be white pixel, and any value lesser than this floor one will be black pixel. Let's submit this and check whether we are getting correct output or not. No, we have to display this. All right, so here I'll be writing IM show BW. Yep, all correct, and here we are getting this one like this. But if you observe this particular one, you can understand that it is not at all thresholding properly, right? Because here the text part is completely going. So let's see what is given in the next task. Plot the intensity histogram for GSADJ. All right, so here we will be plotting. And let's submit this. So if you observe this intensity histogram, we have basically taken threshold as 255 by 2, which is basically here 255 by 2, which is 127.5, and you can see in this histogram 127.5 will appear somewhere here, which is not at all good threshold value, because this side there is not, it is not kind of bimodal shape, so it will not work. Rather we should take somewhat here, right, near to 200, because this side high intensity and this side will be there, right? So let's we have done this. Let us go to next task and see what they are asking. Threshold GSADJ at 200 and store the result in BW. Let us check with this particular threshold improvement is done or not. So I'll be pasting here the same code, and here instead of floor part I'll be giving 200, right? And here display that. So IM show BW I'll be doing and submit this, right? So if we submit, let's check, see all this correct, and see now this time if you observe this particular one, see the letters are, text is coming properly, and the finger part is coming to the background, that is black color, and this is better segmentation than this one at least, right? So here with this we have completed our 38%, right? If we go to next task and go to next session, okay, right? So now what we have to do, previously we have taken threshold value according to our own. Now as you know that MATLAB has its own inbuilt function to automatic threshold value selection, IM binarize we can do. So that's what practice, use IM binarize to create a binary image BW from GS ADJ and display BW, right? So BW equal to IM binarize GS ADJ, okay, and IM show BW. Let's run this particular piece of code and let's check whether we are getting correct output or not. Yes, correct output, we are getting all correct. Let's go to next task. What it is telling, use IM binarize with the option adaptive. So basically this is adaptive thresholding we are going to do, which works most of the time better than global thresholding, right? To create a binary image GS ADJ, store the result in BW adapt. Alright, so BW adapt equal to IM binarize of GS ADJ, and here we'll be writing second piece of argument as adaptive, okay, right? And display GS ADJ and BW adapt together in montage using IM show pair. IM show pair of GS ADJ comma adapt, and here I will be passing next as montage. Let's submit this. Okay, so all correct, well and good. This is what we are getting for adaptive thresholding, right? You can understand that adaptive thresholding this time is not working better, although adaptive thresholding works most of the time better than global thresholding, but this time global thresholding works better than adaptive thresholding, right? This happens and varies use case to use case. Now we can just improve this. What we have to do, we have to say that the foreground polarity is dark. Here adaptive thresholding is happening considering foreground polarity as bright, as it generally happens, that white part as foreground, black part as background, right? So what I'll be doing, I'll be just simply copying these two pieces of code and I'll be pasting here, giving two more piece of argument, that is foreground polarity, and that will be, I will be specifying dark. Now let's submit this and see all correct, and see this time better segmentation we are getting. Let us go to next task. It is completed. Let's go to next session, right? 41% completed. Let's hope we'll be completing this soon. And see, now this time, as I was discussing, that this particular project is nothing but about classifying whether a particular captured image is received or not. Now whether a captured image is received, how you can understand? You just observe this one. This is one binary image, suppose, okay? Now see, just read this one. You have improved the visibility of the text in a binary image. Yes, already using image pre-processing, image segmentation, we have accomplished that. Now, how can you determine whether image is received? The answer lies in the pattern of the text in the image. See, if you observe any received, that is this kind of horizontally text are present, that is text, then some white part, then again text, then some white part, like this it is coming, right? So rows of pixels containing text has more zero values. If you consider a horizontal line, okay, if you consider in this particular part, see this is completely white, okay, but if you consider a horizontal line which is going via the text, that time in that particular row more number of zero values will be present compared to this line where actually no text is present, right? And rows between lines of the text has more ones. See, here one text is present, here another text is present. In between that there is one particular gap, white gap is present, where more number of ones are present, right? If you sum the values across each row, okay, and rows with that time, what you can observe, that rows with text will have smaller sum than rows without text, okay? So if you just plot this sum row wise, you will be getting this kind of nature, okay? So see what actually happens. Initially in this whole region, row wise I am going means from top to bottom, horizontal line consider. So for first horizontal line completely white, so if you sum you might get total as 400. Okay, then next row, like that. When you will be reaching this particular one, when some black pixels are present, the row sum will decrease little bit because here zeros are present, right? So it is decreased. Then again for this particular, all the horizontal line present in this particular region, okay, for whole row, entire row, zero value is present, so you will be one value is present because complete white, so you will be getting again the row sum as 400. Why 400? Because in this direction actually 400 was present, right? 600 cross 400 was my image, so that means in each row there are 400 elements present, right? Okay, I hope you have understood. Then again when we are coming to this particular line, see in this particular horizontal line what will happen, here text is coming, so these are zeros, so basically row sum will decrease, and then in between again two text there is basically one white gap, so again row sum will increase. So this kind of oscillatory pattern you can observe in any receipt, and this will be our weapon to just classify whether an image is received or not, right? So we got the algorithm, now we have to work on how to calculate row sum. So see, you can compute the sum across row using the function sum, pass the binary image and pass 2, which will indicate row wise sum we have to take. Compute the row sum of BW and store the result in S. Where we will be getting BW? BW will be generated from this particular piece of code, which we can clearly see here. Okay, so BW is this one. Right, so here we will be storing the result in S and sum of BW, comma 2. Let's run this. Yep, all correct. Go to next. Use plot function. So let's plot this. Plot S. Let's check whether we can get that kind of oscillatory pattern or not. See how beautifully this kind of oscillatory patterns are coming. Okay, because this particular image is basically one receipt. You can see the first image is receipt I. Okay, so I is one receipt, so that's why this kind of oscillatory pattern in row sum is coming, right? Let's go to next task. Compute the row sum of BW2 and store the result in S2, then plot S2, right? Very simple. So S2 equal to sum of BW2 comma 2. Okay, right, and plot S2. So see what is our S2 image, this kind of moon. So here this kind of oscillatory pattern in row sum we should not expect, right? Let's run this and let's check what result we are getting. So see here we are not getting that oscillatory pattern which you can observe in receipt, and this is the importance of feature extraction. Here we are extracting row wise sum feature, which is specifically useful for classifying whether an image is script or not, because that time this kind of pattern we might get. Let's go to next task. This is future practice, you can explore. I am going to next session. Okay, here what we have to do, select image 7 from the drop down list. Okay, right, so here from the drop down list we will be going to image 7. Do you see any features of the image that could distort the row sum? Let's see. Yup, here there is problem. Here the pen is coming which is distorting the row sum, and as a result we are getting this kind of distorted version of row sum, right? So let's just run this. Just here the task is we need to just choose image 7. Go to next task. Set the drop down to image 10. I'll be going to this and I'll be selecting image 10. I'll be just clicking on submit. Alright, so here also row sum pattern we are not getting because of the background. You can see in background is such that this kind of things coming, and this also considered as black part as a result, which is affecting our row sum, right? Set the drop down to image 2. We'll be doing that, and let's submit. So in image 2 what problem is appearing? In image 2 in the background side this kind of ruled notebook is present, and due to which our row sum is distorting. Okay, so these are different edge cases where our this particular row sum algorithm might fail. Okay, so we need to handle all this using post processing. Now we have appeared in the post processing stage. We have already completed importing, pre-processing, segmentation, and now we are going to post processing. What we are going to do in the post processing, we are going to first apply kind of noise removal. Okay, because noise affects our thresholding by a huge amount, and for noise removal we have studied. For median filter we can use for removing salt and pepper noise. Mean filter we can use for removing noise also. Okay, background isolation and subtraction also I have discussed. Binary morphology, this kind of thing also I have discussed. Eventually I'll be showing you one by one and you'll be understanding. I'll be clicking on next directly instead of looking through the video. Okay, 54% of the course is already completed, right? So here you can see image noise. So this part is basically discussion for removing noise. What it is asked: create a 3x3 average filter and store the result in age, right? So here I'll be using if special function, right? And here I'll be passing my image. So here a special we have to create the filter only, average and 3 cross 3. So I'll be passing second argument as 3. Submit this. So as expected, this is average filter, so all the elements will be 0.1111, right? Because 1 by 9 is 0.1111. Sorry, 1 by 9, right? Let's check once. 0.11. Let's go to the next task. Well, obviously we have to filter and make smooth image. Why smooth image? Why noise removal required? See, this particular image, highly noisy, right? So as a result, when you are taking thresholding, this is distorted. So we need to first filter. Okay, so here we need to store the image in gsmooth. gsmooth equal to im filter Grayscale image gs and filter age we are passing, and store the result. Let's check. Yep, correct answer. Create a binary image gsmooth using im binarize adaptive foreground polarity dark. Yep, we have seen this, that how to do adaptive thresholding, and we need to put in bw smooth. bw smooth equal to here we are going to use binarize of gsmooth, and here I'll be using adaptive, right? Then next parameter will be foreground polarity, and here we'll be writing dark. All right, here it is dark, and store the result and display it. See, all these things I have discussed, but the feature extraction for receipt, this is the new concept which you are learning, right? So this is our adaptive thresholded image, right? If you look closely, you can see the filter introduces small unwanted dark outline parts. See here, dark outline parts are coming. See, this one is also outline, this one are outline, and the reason is that here basically while doing our filtering this part, we have not specified how it should handle the border pixels, right? Okay, and for this, if we use replicate function, this can go away, because replicate will basically replicate the border line and will apply our filter on that, so that will not be getting this kind of black pixels, okay, in the borderline, because black pixels coming because by default our this im filter function introduces or append 0 value at the borderline and apply filter, right? So instead of that, we'll be using replicate property, right? So here apply the filter age to the Grayscale image gs as you did in task 2, but use replicate. All right, so here I'll be just simply copying this and pasting it here, and here I'll be copying this, and here I'll be pasting it here, okay? But here this time I have to use replicate. Yup, correct. Now, binarize GS smooth as you did in task 3. Store the result in BW smooth. Display BW smooth. I'll be copying this too. And let's submit. So see, this time in the border side, no extra lines are coming which was appearing earlier due to zero padding in the border lines, right? So this is the power of replicate property. Okay, so now isolating the image background. Here you can see that background is present, okay, and we need to isolate that so that we can get like this. So 61% already completed. I'll be continuing my discussion in my upcoming video. Thank you.